I want to talk about the objective, define condensation polymers and relate them to esters. So condensation polymers are essentially, we know what polymer means at this point in time for sure. A polymer is a large molecule, a macromolecule that's joined by repeating subunits that we call monomers. And you've probably heard about these in a lot of other classes like biology. We've talked about them with our addition polymers. So way back at the beginning of the quarter, we learned about addition polymers, such as, PVC pipe. So PVC or polyethylene, it's a really common one of an example. And they're called addition polymers because the monomers are joined through addition reaction. So remember, our addition reaction was our alkene addition reaction. And so if we add across that double bond to create then some new bonds, and all the other bonds are the same. So that's polyethylene is an addition polymer because of the way the two monomers are joined. So a condensation polymer is when our two monomers are joined, monomer plus monomer, to yield more monomers, and on and on and on. These are linked together just poorly. So a condensation polymer, excuse me, is one where the monomers are not added together through an addition reaction, but added together through a condensation reaction. So in that case, we're not adding across a double bond, we are joining them together through the loss of a smaller molecule, and typically that is water, another part of that name. So not only are we condensing them into smaller structures, we're doing so through the loss of a smaller molecule, in which typically is water. So then in terms of condensation polymers as they relate to esters, is that kind of polymer, which we often will call a polyester, many esters, happens through creating an ester linkage. So we want to review what's an ester linkage. There's an ester, so this is an ester linkage. So if that's the type of bond that is joining our monomers together in the polyester, if that's what's happening right here, that's a polyester. And if we think about how we make esters, we often make, one of the ways to make esters is by reacting a carboxylic acid with an alcohol. And that's how we can get that linkage. And what do we lose? What's lost through that process? A water molecule. So an H2O molecule right there. And so what that means is that on one side of the molecule of our monomer, we must have a carboxylic acid, the carboxylic acid group. And on the other side, we have to have this other kind of group that can give us this ester linkage. So this is then an alcohol group. And so then those can link up to make that first bond, which means that the monomer, let's kind of move over here to talk about, here's my jelly bean version of the monomer for a polyester, not just any monomer, the monomer that create a polyester, it has to have both of these groups in it. It's got to have a carboxylic acid on one side. So on one end, I wanted the double bond to be up there. We'll make that a single bond. It has the carboxylic acid. And on the other end, it has an alcohol group, some type of OH group. And that's, so then in one molecule, we have these two chemically reactive species. Now the molecule's probably too short for them to cycle up and react to each other. But what that means is they can react with another one. You can put another monomer next to it, and its carboxylic acid functional group can react with the alcohol, and then you can repeat and repeat and repeat, which kind of leads us to an interesting, how do we get a monomer like that? Well, and the book kind of, I thought, does a good job of explaining that we would need a diol, a molecule that has a hydroxyl group at either end, and we could react it with a dioxylic acid, one that has, so here you're getting really fancy jelly bean molecules here, one that has a carboxylic acid group at both ends. Because then these two groups could react together, and then we end up with then like this monomer that has these corresponding functional groups that are reactive to each other on each end. And so it kind of then makes them able to link together over and over and over through what we call a condensation reaction. And that is what a polyester is. And there's lots of different kinds of polyesters, but we know from that name polyesters, they are many ester linkages. So ester linkage, ester linkage, ester linkage, ester linkage. So we know then that this is the linkage that they have between them. And if we were to separate them, we would get these functional groups back on either side. So condensation polymers are polymers created through a condensation reaction, and an example of those are our polyesters. So in order for a polyester to form, the carboxylic acid of one end of one monomer will react with the alcohol group of the next monomer. That next monomer, though, still has its own carboxylic acid group open and available to react with the alcohol of the next, and so on into eternity.